Recording. Okay, perfect. Hopefully I have more people today. I think last week we just had so many crazy things going on. I know with fall break in October, it's just chaos. But anyways, I'm so glad we're all here for today. Today our icebreaker is what universe would you want to live in? And I'm already starting to see some answers, so let's take a look. Amari says, of course, Harry Potter, even though he's never watched this series at all. I think okay, I would at least either read the books or watch the movies. You don't have to do both, but I would do one or the other. I think it's a good example of like what a story should look like. But I think the Harry Potter universe is a great universe to live in. Amari also says, though, later on, me and my friends make comic collabs, and we have this spectacular universe even though the main character dies once in a while, but overall a great universe. Okay, I just love that the main character is just resurrected casually. Like that's awesome for you guys. But that sounds like a wonderful universe, Samari. I think it's awesome that you're doing comics. That's such a cool thing. Let's see. Okay, Amor says I've only seen one book. Okay, my cousin had like all nine DVDs or something, so we just sat one week and watched them. I think the for a book adaptation, it's actually pretty good. It's not a horrible adaptation, which is why I would recommend like watching it if you don't want to read. But read books. Book reading is good. Doris says Percy Jackson. Nice, yeah. So a lot of mythological fantasy universes. Kavi says Harry Potter. Um, Oh, Amari says there's a reason they get resurrected. That is very interesting. Poppy says Wicked. Oh yeah, Wicked fan. That's awesome. Um, I wonder when Wicked 2 is coming out. I haven't is this like a is Wicked 2 coming out like soon? I have no idea. But I did like Wicked 1. I thought the plot was a little slow. I thought that obviously the cinematography was great because it was a high profile film, but I thought it was a little bit slow. And also I'm not a fan of musicals, so maybe that's part of it. Oh, Wicked 2 is coming out in November? Wait, that's actually really soon. I'm surprised I haven't seen any promo for it. Maybe I'm just like not on the right side of the web, but it's okay. Yeah, it's coming out on November 21st. Okay, I've seen like no promotional stuff on it. But that's okay, I guess. I'm not really missing out. Awesome, awesome. Okay, for those of us who are just joining, let us know what movie universe would you want to live in? Radhia says Harry Potter as well. Okay, awesome, awesome. Radhika says, I don't know. Well, if you can't think of a movie universe, you're welcome to give like a book universe or like a TV show universe. And it also like doesn't have to be fantasy. Like it can be like a sitcom or something. Like maybe you want to live in the Friends universe or something. Um, but yeah, it could honestly be anything. Like what alternate universe would you want to live in? I'm actually really surprised no one has said the Marvel universe yet. I feel like I thought that would be a pretty common answer, but maybe it's just like too vast and generic and nobody really cares about it, which is like fine too. I think there's a lot going on in the Marvel universe, so oh, what did Jason just send a picture of a line? Okay, I don't know why I downloaded that, but that's okay. Amari says the Marvel Universe is cool too. Yeah, yeah, yeah. Okay, so here's an actually, you know what? I think we'll save this for another icebreaker. I was gonna ask like Marvel or DC Universe, but we'll save that for another icebreaker. Um, Doris says, I just want to be in one with a superpower. Yeah. Wait, okay, so there's a lot of stuff with superpower. I'm thinking like because a lot of like old like 2010 shows that I watched growing up, like those all had like superpower stuff like Casey Undercover. I guess that's not superpower necessarily, but like I don't know, that's pretty awesome. What else? There's like Mighty Med, which is like the superhero hospital thing. Wait, I like low-key still watch some of these because they're like really good. They have like good plots, which is like a little childish of me, but sometimes it's like better than whatever is being released these days. Um, but yeah, lots of good superhero stuff. I think that's a good option, being in a universe with superpowers. But Becky says Harry Potter as well. 27 says myself. Wait, 21, can you like DM me your name or something? Because I hate having to say like the numbers 21 out loud. If you can DM me your name, like that'd be great. You can keep your 21 user thingy, but just DM me your name. Percy Jackson or Doris says Percy Jackson is awesome for superpowers. Totally agree. I have a confession to make. I actually never read Percy Jackson, so I don't really know much of the premise, but that's okay. Oh yeah, I love Phineas and Ferb. That would honestly be such an awesome universe to be in. I think Phineas and Ferb. Like I would want to be like one of their friends, not like Candace or something. But yeah. Oh, Dora says Bluey as well. Yeah, yeah, yeah. Awesome. Okay, well, it is 7:05, so I think let's go ahead. Oh, wait, just kidding. I do see some more answers kind of trickling in. Okay, Amari says Phineas and Ferb. Yeah, yeah, yeah. I think that's like such a fire universe. I was like rewatching the show recently. I watched season 5 as well. It was pretty good actually. It's really surprising their voices are all the same after like 10 years. But yeah, it's such a good show. Manate says Harry Potter. Nahal says Naruto. Kavi says Keeper of the Lost Cities. That is actually a really good universe. I feel like we talked about this before, but I remember like one class I mentioned like this author, like I forgot her name, but she literally releases books way too much. Like I feel like the series could have ended like 5 books ago, but that's okay. That's okay. It's a good series nonetheless. Yeah, Jason also says Phineas and Ferb. Okay, awesome, awesome. So let's go ahead and actually jump into the math now that some of the answers have died down. So today we're gonna step away from the crazy world of triangles and look at the I think much more fun world of plane geometry. It is not plane as the name suggests. It's like a plane. Okay, that's a really bad joke. You guys will get it. But today is like the fundamental side of things. So maybe a lot of this will be review, maybe not, but that's okay. We'll go through it pretty slowly. And then let's see, what was I gonna say? Okay, so we'll do some like intro to like coordinate geometry, which is what I'm talking about, if you guys don't mean plane. Um, but we'll do some coordinate geometry, we'll take a look at some problems, and this will set us up for some really cool stuff going forward. Interestingly, a lot of geometry problems can actually be solved using like coordinate geometry and plane geometry. Sometimes it's not the most optimal approach, but it does work. So depending on how much patience you have, there's definitely lots of things to be done with coordinate geometry. This is probably like the one thing in geometry that I'm actually good at. But that's okay. That's because plane geometry is very algebra based, and I'm okay with algebra, so that's why I like this. But I think it's for like true geometry lovers, it doesn't really like go into the beauty of geometry, but that's okay. That's okay. We'll talk about it. It's a good concept nonetheless. Okay, so let's get started. So what am I saying like plane geometry, right? So some of you guys might think I'm saying like plain, like it's boring. No, I am talking like aeroplane geometry, like this plane. So yeah, there we go, like plane, like airplane, but it's also not an airplane. I just realized like how many different like homophones there are. But anyways, yeah, plane geometry. So you guys are actually looking at a plane right now. This space on my screen is a plane. It is a coordinate plane. And we can kind of like draw some axes actually on here. Like this might be helpful for today's class. So here's some axes for today. Oh, that was really horrible at the end. I don't know why it got all crooked like that. Okay, so we got our y-axis up here and our x-axis. I'm sure you guys all know about that. But yeah, so this is our plane, a really nice plane. So plane is any flat 2D surface. So pretty simple definition. I think we talked about that one week as well. So just a good review. Yeah, Jason says airplane. Awesome. Okay, so we can do, oh, is today going to be hard? I don't think so. I think a lot of this is like pretty intuitive or like it applies concepts you guys have already done. So I think it'll be a good break from all the craziness of triangles. But it will maybe get harder. Okay, so on a coordinate plane, we obviously have points. So we'll say like this is, oh, where did my pen go? Okay, so we'll have like a point here and like a point, let's say, I don't want to do one there here. Okay, I don't know. Can you guys see like these grid lines or are these like way too faint? Let me know in the chat. Okay, you guys can see those, right? Okay, so assume like every grid line is 1 unit. So okay, I'll like help you guys out a little bit. So this is like 1, 2, 3, 4, and so on. And then it's the same thing kind of on here, like 1, 2, 3, 4. Okay. So yeah, this is like kind of small, I know. Okay, so can you guys tell me, and maybe I should have done this with different colors. Tell me what the coordinate of the red dot is. Like what's on the red dot? Where is the red dot? Yeah, it's 2, 2. Awesome. And what about the orange dot? Okay, 4, 3. I did see 1, 4, 4. Just be careful if you're counting, but yeah, 4, 3 is correct. So Good work to everyone who has put that in. So many names. I wish I could say them all. But there's just so many people, which is good because a lot of you guys are understanding what we're doing. Okay, amazing. So we have 2-2 and 4-3, which is awesome sauce. Oh, and we also have a picture from Nahal in the chat about what a coordinate plane looks like. Great. Okay, so this is like pretty intuitive. I feel like most of you guys already know this. In case you're like confused about how we're writing points, in general, a point it's a dot, and it's denoted on the plane as x comma y. So it's however many points from the origin that you go left or right, so in the horizontal direction. And then the y thing is how many units you go up or down. So in the case of the red dot, you're going 2 units to the right and then 2 units up. So we write that as 2, 2. And in the case of the orange dot, you are going 4 units to the right and 3 units up. So that is 4, 3. Lovely. And let's try yellow today. Okay. So kind of like based on this scale that I've given you guys here, can you tell me what is at this point? Oh, that yellow is actually like visible. Amazing. I'm also going to see if I can maybe make these grid lines like more apparent. Okay, I don't think that is a thing. That's okay. But that's okay because you guys can see this anyway. So yeah, we have -2, -3, which is nice that you guys did not get confused with the negatives. All we're doing is going 2 units to the left this time, so that's why it's negative, and then we're going 3 units down, so that's why that's positive, or sorry, negative as well. So -2, -3. Maybe I'll like label these again. So this is like each unit. Yeah. Okay. Yeah, it's just like two number lines. Like one is a horizontal number line and like one is a vertical number line. And you're kind of just like counting along the number line to get to a certain point. So like this is intuitive. We don't need to spend more time on this. What I do want to spend more time on is like what you can actually do with these points. So given these 2 points, what are some things that I can find about like these two things together? Like what are some things that might be of interest to us? Oh, can I not use yellow? Yes, I will stop using yellow. But I can use a dark blue. Okay, so let's see. Anvika says we can find slope. Awesome. Dora says distance. Amari says distance. Perfect. And Manit says slope. Anvika says midpoint. It says slope again. Distance, slope, slope, midpoint, slope, distance, midpoint. What the heck is slope? We will get to that. Amari says the location of a place. Well, I don't think we can find the location of the place, right? Because that is the place. Like 2-2 is the place. But yeah, okay. So I think these are like the three properties that we can find. Like, and it's really good that you guys know this. And because you guys are saying all these terms, I assume like you probably already know the formulas, but we'll talk about like where they come from because maybe that gets skipped over. I think it's like some of these are pretty intuitive though. Okay, amazing. So let's start off, let's do slope later, and let's start off with midpoint. I feel like midpoint is really easy. So when we're finding the midpoint, we're literally finding the point, the place that is in between both the x coordinates and both the y coordinates. Okay, that's gonna be exactly in the middle of these 2 points, right? So you know what? Let's get rid of this like negative here because no one likes the yellow and we can deal with the positives. And actually, I don't know why I just clumped everything. Oh no, I lost my x-axis. I don't know why I just clumped everything in like one corner. So let's fix that. Uh, can I like erase these really slowly? Okay, my apologies. Okay, so this time, here's what we'll do. And I'll erase these points as well so you guys can actually see things. So this is 1, 2, 3, 4, and 1, 2. Man, there's like no space here. Okay, let's like move the x-axis down, I guess. Oh, no. Wait, you guys are like dealing with all my technical difficulties. I so appreciate your patience. So we'll do like this kind of thing. Okay, so I'll fix the points, but I think it's like kind of clear where I'm going with this. Um, no. Oh my goodness, you guys. I'm so sorry today. Like tech is like not my thing right now. Okay, so we got 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. Okay, lovely. So now that we have these, let's do 2 points. I'll do a point over here. Or actually, let's do one like over here and like one like over here. Okay, so these are my 2 points, right? Let's find the midpoint of these. Let's find the midpoint. I'm not gonna tell you where these points are. I feel like that's pretty intuitive. But based on like these locations, tell me where you think the midpoint is. It may be a little bit messy though. Okay, Amika says 3, 2.5. Kavi says 3, comma 2. Manate says 3, comma 2.5. Let's see. Oh, I just realized like my point is a little bit off here, so let's quickly fix that. Sorry, you guys. Oopsies. Dark blue. Okay. 3, 4, 5, 6. Okay, so I'm seeing a lot of like 3, comma 2.5, and I think I'm going to agree with that. So let's first label the points, right? So we're obviously going 1 unit to the right, 3 units up. So this point is 1, 3, and then this point we're going 5 units to the right and 2 units up. So this is 5, 2. So like I said before, the midpoint is exactly in between of these. So let's say I draw like a line, right? Let's draw a red line, like Christmas colors. I'm connecting these 2 points, right? The midpoint is going to be the center of this line. So we'll say my midpoint is right about there. Okay. Now, in this case, and this is probably like the only time you're ever going to see this, this diagram is actually to scale. So you can like eyeball it and say like, yeah, that's at the 3x coordinate, and this is like roughly halfway around 2 and 3. So I'm going to say that's 3 comma 2.5. That works in this case because I drew the diagram to scale. But if you don't actually have a diagram to scale, which is very, very common, you actually have to understand how to get to the midpoint, right? So let's talk about what the midpoint is. It's the thing right in between the x coordinates and the y coordinates. So if we look at the x coordinates, 1 and 5, what number is directly in between those coordinates? Those numbers. I think someone mentioned like how they did this before using mean. So Amit says 3, Radhya says 3, and yeah, that's absolutely correct. The middle of the two x coordinates is 3. What about the y coordinates? What number is exactly in between 3 and 2? Yeah, 2.5. And maybe that's like a little odd, right? Like, oh, we're using a decimal. Well, a good way I like to think about this is you're just taking the average of the 2 points, right? So I'm taking the average of my x coordinates, 1 and 5, and Anvika puts that in the chat. That's x1 plus x2. So 1 plus 5 over 2, we take the average, and that'll give us 3. Similarly, we can do the same thing with the y-coordinates. I take the average of 3 and 2, which is 3 plus 2 divided by 2, which is 2.5. So that final midpoint is 3 comma 2.5. Okay, awesome. So I think that was hopefully clear to everyone. A lot of you guys already got that answer. But yeah, so that's what the midpoint is. I feel like so like the formula exists, but I feel like it's so many symbols that it's not helpful. All you have to really know is like the midpoint is the average of the coordinates. And you know what? Maybe I'll write that because that is probably more helpful. Yeah, so to get x, you kind of just take the average of the x coordinates. So in this case, the x coordinate is 1 and the other x coordinate is 5. So taking the average of that, you get 6. So that's where, or you get 2. Or you, oh my God, I'm so sorry. You get 3. You get 3, which is the average of 1 and 5. So yeah, that's where the 3 comes from. I am so sorry. Okay, multitasking is clearly not my strength. So we'll say average of respective coordinates. And I will abbreviate coordinates as COORD, coord, because I don't want to write the whole thing. Okay, so that's what the midpoint is. The other thing we can find is distance. So let's go ahead and find distance, right? And I kind of have the distance drawn here. So this is our fancy line. We want to find out how long this line is. Any ideas for how we can do that? Like, how can we find out how long this line is? Well, you guys think. I will find another color to use. Okay, let's do like, let's do this like, oh, I don't want to use the ugly orange. Okay, we'll do dark green. Yeah. So how can we find the length of this line? You're gonna have to look a little like closely because it's not super apparent. But how can we find it? Okay, Envika, I think that's Envika, right? Yeah, okay. Envika has put in a formula in the chat. That's a lot of symbols. Break that down into like meaning. What does this actually mean? Like all these numbers. What are we really doing here? Minute says make a third point to make a right triangle and then you Pythagorean theorem. Yeah, you use Pythagorean theorem. Good. I like that. I like that. Jason kind of goes about something similar. You kind of look at the x and y distances, and then that's going to be like your hypotenuse. Okay, so look, it looks like we're kind of going in the same direction, right? Anvika also says make a triangle. And Minnie helps us out a lot here by telling us where exactly we can make the triangle. It's at the point 2, comma 1. And if we go ahead and draw like a little dashed line, more dashed lines. Okay, so, sorry, that's right, 1, comma 2. Wow, I am so off my game today. Thanks, Minnie, for correcting that. Yeah, I wrote that. And thank you, Kavya, as well. Amazing. You guys are doing awesome with me today, like being super patient and everything. Okay, awesome. 1, comma 2. Perfect. Um, yeah, you can actually also make a triangle up here. I think this is a little easier to see. I just like my triangles like facing down like this. Okay, and now it's pretty easy to see that the distance is just the hypotenuse of this triangle. So let's take a look, right? What's the height of this triangle? It's just 1. That's pretty easy to see. You can also subtract the y coordinates, so that'll be 1. What's the length of this triangle? 4. Amazing. Once again, you can count the units, but most often you'll have to subtract the distances. So you'll do 5 minus 1 to get 4. And based on this, can you guys tell me what the hypotenuse is? What is the distance between these 2 points? So the distance is the square root of 17. Perfect. So we basically just use the Pythagorean theorem once again, right? So 1 squared plus 4 squared is equal to 17. Take the square root of that to get the hypotenuse, and that is square root of 17. Okay, so the only tricky part was figuring out like where do we put this point to get a triangle, right? The nice thing is you basically what you have to do is you kind of look at the one x coordinate and you look at the other point and take its y coordinate. So that's where 1, 2 comes from. You could also do like 5, 3. You're looking at this x coordinate and this y coordinate. So pretty neat how you can make a triangle and then figure it out from there. Maybe you don't have time to make a triangle. So in that case, I would say the formula is find the distance between the x coordinates, 4. Find the distance between the y coordinates, 1. And then apply Pythagorean theorem on that. You don't have to do all this diagrams. I just think it's a good idea to understand like where this actually comes from and why we can use Pythagorean theorem. Okay, so the main idea for the distance is, let's see, this is equal to make a triangle, like make a right triangle. Lovely. Okay, and finally we have slope. So slope, we are kind of looking at how much the x changes and how much the y changes in relation to each other. And to calculate slope, we once again return to the amazing line that we have here in dark red. Clearly, this is a very important line. And I do see some definitions from Kavya and Anvika about slope. So Kavya says it's the rate of change, which I absolutely agree with. And Anvika says it's the inclination of the line that passes through the 2 points. A very technical definition that is also absolutely correct. So yeah, great work to both of you guys for putting that in the chat. I think that's awesome. Oh, yes, I got tagged in the chat. Thanks, Jason. Let's see. Nahal says, oh, that's not a question for me. Atharv says, oh, okay, so really quick, Atharv, back to the previous one. All we're doing here is finding the hypotenuse, right? So we have a right triangle with legs 1 and 4. So we just use Pythagorean theorem. The square root of 1 squared plus 4 squared is equal to the square root of 17. So that's where that distance comes from. Okay, awesome. So let's now talk about slope, right? So we're looking at slope, we're looking at the rate of change. And this is one where I do have to give you the definition. So we define slope as, let's see. Okay, we'll do like, I'm gonna give you guys some crazy symbols. This is slope. Does anyone know what these little triangles mean? You guys know what that means? Yeah, and because it's delta. And Kavya says change. Very good. So, oh my God, I feel like I've used everything already. What should I do? Let's use, okay, I guess I can use this dark, like, red thing. Okay, so magenta, or not magenta, the delta sign is this triangle. It is a Greek letter, and it is used in math to show change. So whenever you see a delta in front of a variable, you're looking at change in that variable. So delta y is change in y, and then divided by delta x is change in x. So the slope is change in y over change in x, just like Kavya put in chat. Awesome work. Thank you, Kavya. So yeah, that's slope. And that's why I have to give you a definition because this is not like the idea is it's rate of change, but there is a specific way. Like if you do change of x over change of y, that is not slope. That is wrong. Slope is y over x, okay? Another way I like to think of this is like rise over run. So it's like how much you're rising divided by how much you're running horizontally. Okay? So based on that knowledge, can you guys tell me what is the slope of this magenta red line? I think the number's already there, so you kind of just have to like put it together now. Okay, Anvika says negative 1 over 4. Kavya says negative 1 over 4. Manit says negative 1 over 2. Manit, check your numbers. I think you're close. He says negative 1 over 4. Okay, Cypress says negative 1 over 4. Yeah, Minnie says negative 1 over 4. Jason says negative 1 over 4. Amazing. So many negative 1 over 4s. Thank you also to Nahal and Rathika. Yeah, so let's take a look, right? We read a graph going from left to right, just like how we read English. For some reason, that idea confused me a lot. As a kid, I always used to say, like, why are we not going from 5-2 to 1-3? Like, how do we know we're going from 1-3 to 5-2? That's because 1-3 comes first when you're looking at the graph left to right. So that's why our first point is going to be 1-3, and our second point is going to be 5-2. So notice how we're going from like a higher elevation to a lower elevation. Like we're starting from a 3 y coordinate and then going to a 2. So our line is kind of going downwards, which means like the slope, the inclination is negative. So that means like we should have a negative sign in front of our slope. Yeah, thank you, Kavya. Manit says it doesn't really matter which ones you use. Manit, it actually does. Because if you assume that it's going from 5-2 to 1-3, then you say your slope is going to be 1 over 4. You kind of miss that like negative sign, right? Because it's going upwards instead of downwards. So the sign matters. Like that's why it matters like which point comes first. Yeah. Okay. Um, yeah, yeah. Wait. Is that true? Yeah. Oh, hold on. Let's see. Let's see. Let's finish this first and then we'll come back to that. Okay. So now that we have oh wait. Guys, I'm really struggling with color today. Someone said green, so let's do green. We'll do like a light green. Okay, so looking at the change in y, my first point is 3. And that next one is 2, so 3 minus 2. Okay, that's my change in y. And then my change in x is 1 minus 5. Okay, so 1 minus 5. And then when you solve this, you should get 1 divided by negative 4. So this is negative 1 over 4. Okay, so that's where our slope comes from. Slope is the one time where I say, like, actually remember this formula. Intuitively, though, it's pretty easy to see like you're going down 1 unit and going over 4. Manit, to your point, you are correct. It doesn't matter which way you subtract. I mean, in the sense, like if you're looking at this, as a kid, I used to think, oh, like it's 1 unit and 4, so the fraction should just be 1 over 4. But you have to remember the direction in which you're changing, right? So you're going down 1 unit, which means it's negative 1, and you're going across 4, so that's positive 4. So that's where the negative 1 over 4 comes from in this diagram. Okay, so these are all the things that we can figure out given 2 points. We can figure out slope, distance, and midpoint, which is actually a lot of information, right? And I'm sure some of you guys can already see how some of these things are actually like pretty useful in problems. Maybe not yet, but we'll see. Okay, cool. Lots of great comments in the chat so far. Um, awesome. Okay, so let's go ahead and kind of move on. I'm thinking like, where do we want to go next? Do you guys want to discuss more on like different types of slopes, or do you guys want to do some like easy-ish problems? When I say more on slopes, I mean like, do you guys want to talk about like uh, parallel lines, perpendicular lines. Okay, so I do see, I do see. Okay, I do see a lot of people saying like talk more about slope. So I think we'll talk about slope for like another 20 minutes and then end on challenge problems for today. Um, yeah. Okay, let's do that. Okay, so do, do, do. The beautiful thing about plane geometry is everything comes down to points and lines. Every problem can be represented as points and lines, which I think is like super neat. So I'm going to clean up this part and kind of leave my grid because I think that's helpful. I will also leave these definitions here for you guys because I think this is also helpful, but I will make some more space for it. Okay, perfect. So these are our things. Awesome. So let's talk about a couple things, right? So I'm gonna put 2 points back on the screen again. Actually, let's do slope and then we'll talk about equations. So um, let's say I have a let's say I have like some line over here. Oh, that's a horrible line. Some line, okay? Um, and let's say I have another line perpendicular to it. Okay? Can you guys tell me like what do you guys think? Oh, maybe like this is not the best example. Hold on. Let's do, okay, I realize like that is not helpful. Let's do like this is one line, so we'll have a point here and a point here. Okay, and then we'll have a second line that's perpendicular to it, and it kind of sticks out like this. Okay, so this is our second line. Can you guys tell me what is the slope of the green line? So the green line starts here and ends here. What is the point of that green segment? The slope. Think about change in y over change in x. Okay, Vishit says -1, Nahal says -1. Yeah, the question is, what is the slope for this green line? -1. Okay, good. And that is absolutely correct, right? So once again, we're going down 2 units we're going down 2 units and going across 2 units. So that means our slope is negative, right? So we have -2 divided by 2, which is -1. Okay. What about the blue line? What's the slope of the blue line? Yeah, it's just one. So thank you, Kavya, Darav, Manit, or Anika. Oh my goodness, so many people. Bye Sanvi. Awesome job, you guys. Dora, Atul, amazing. So this time we're going across two, so 2 units in the positive x direction, and we're going 2 units up in the positive y direction. So 2 divided by 2 is just 1. Okay, now I did say these lines were perpendicular, right? And that's because I drew them that way. So these things are perpendicular. So can we say something about the relationship between the slope of the green line and the blue line? Like, what's their relationship? Do you guys see anything? Yeah, no, you're good to go. Make sure to watch the recording now. Okay, Advika says it kind of just looks like they're negative. Yeah, it kind of just looks like they're negative. That's about it. Okay, let's look at another example. Maybe this was just a coincidence. Let's look at another example, right? So I'm going to tilt these lines just a tad, and maybe I'll extend them too. Oopsies, that's not what I wanted to do. So let's rotate these just a bit. Wait, how do I want to do this? Okay, I guess we can do it like this. And then kind of like fix that. Okay, give me a moment to fix this, you guys. Actually, you know what? I might have just restarted. I don't know why I decided to bother with all this rotating business. Okay. So this time we'll do a line that goes like this. Okay, so oopsies. So this is a line, starts over here, ends here. And we will have another line that goes like this. So this is also very clearly a right triangle, but this time they both have one vertex in common. Okay, so once again, what is the slope of the green line? What is the slope of the green line? -1/3. Thank you, Anvika, and thank you, Kavya, and Vishith, and Manit, and Vaidehi. Awesome work. Okay, yeah, so the green line slope is -1/3. We're just going down 1 unit, so that's -1 in the numerator and across 3 units, so +3 in the denominator. And what is the slope of this blue line? Yeah, Manit and I think Anvika and Vaivahi and Jason and Rishith all say 3, which is absolutely correct. Because this time we're going 3 units up and 1 unit to the right. So that is 3 units up, that's the change in y, 1 unit to the right, that's change in x. So 3/1 is equal to 3. So that's where the slope of the blue line comes from. Okay, so what's the relationship now? Is it still just negative? Ah, Nika says it's the opposite reciprocal. Okay, neat, neat. What do you guys think about this idea? Does this make sense? Like opposite reciprocal? I would say maybe instead of opposite, let's use the word negative. So this is like the negative reciprocal. The slopes are negative reciprocals. Does that kind of make sense, you guys? What do you guys think of that? Okay, Athar says kind of. Yeah. The best way I can explain this right now is kind of just giving examples. There was probably like a nice geometry proof for it, but I don't want to really get in the weeds. So for the time being, let's just say like if two lines are perpendicular, their slopes are negative reciprocals. And this is an accepted fact. Like this is a fact. It is a law of coordinate geometry. Reciprocals. Okay, lovely. So now let's say we have, I think we've established what happens with perpendicular cases. So let's say we're now working with parallel lines. Okay, so let's say I have a line that kind of looks like, let's say I don't want to do like a boring slope again. So let's say I have a line that looks like this, and I have another line that kind of looks like, did I do that right? Okay. Yes, I did that right. Those don't intersect, I think. Yeah, okay, that's good. Okay, so these two lines are parallel. Whether you believe it or not, I have made them parallel. So what's the slope? Oh, I should not have made them both orange. That was very silly. Um, what's the slope of the orange line? Okay, yeah, -1/3. Oh, Jason, I do see your picture. Let me use that after this problem. Yeah, thank you for sending that. I will use that afterwards. Yeah, so -1/3. What about for the blue line? What's the slope of the blue line? Yeah, it's also -1/3. That is absolutely correct. So pretty easy to see like where these slopes come from. So what do you guys think the relationship is for parallel lines? Yeah, their slopes are the same. Perfect. So I'll write that up again here. So slopes are same. Okay, awesome. So perpendicular, that looks like this. The slopes are negative reciprocals, and if they're parallel, the slopes are the same. This one is easier to understand because remember, parallel lines are lines that never intersect. And if we have two different slopes, the lines are bound to cross at some point. And you'll kind of see this when we look at expressing lines in point slope formula or slope intercept formulas, which I think Manit has put in the chat and Kavya did as well earlier. So yeah, that's why like parallel lines have to have the same slopes because that means they will never ever 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 intersect, which is the definition of parallel lines. Um, Okay, awesome. So I think a lot of you guys are starting to see where we're going with this, which is really wonderful. Let's see what. Oh yeah, and before we move on, I do want to talk about one thing because I think it's important. And then Jason will go ahead and use your diagram going forward. But yeah, thanks for sending that. Okay, so really quickly, what is the slope of a horizontal line? It's 0, right? Because it's not rising at all. It's x the change in x is 0 because it is just it's flat. There's no like up or down. So for a horizontal line, it just goes infinitely in x. So there is some x denominator, but the numerator, the y direction is just 0. So 0 divided by anything is just 0. So the slope of a horizontal line and I'll represent a horizontal line, kind of like this, is equal to 0. Minute says you cannot divide anything by 0, so it is undefined. Minute, in this case, the x is still changing, but the y is not changing. So in the numerator, you have 0, but in the denominator, you have some other number. So that's why you can do 0 divided by something is equal to 0. Yeah. Awesome. Okay, and then what about a vertical line? What is the slope of a vertical line? Something like this. Yeah, so the slope of a vertical line, and I'll do that as kind of like a 1, that's equal to nothing. It's undefined. And the reason why that is kind of what Minnie was talking about before, right? In this case, our y, the change in y is just forever. It's just rising forever and ever and ever. There is no change in x. So that change in x is 0. And because that denominator is 0, that means you cannot divide anything by 0. It doesn't matter what's in the numerator, nothing can be divided by 0. So that's why the slope of a vertical line is undefined. Okay, so these are a couple of important like definitions, terms, and things. And I think now let's kind of go on to slope-intercept form. So I will go ahead, clear this, and we will use Jason's diagram, which I think is a lot easier to see than what I have written. And let's move these kind of down here. Oopsies. Okay, perfect. And oh man, okay, we'll do a little corner up here. All right, let's see. I don't, can I like drag and drop? Oh man, I have to download it. That sucks. Okay, let's see. I guess I can like, oh, copy and does that work? Allow? Oh man. Okay, that's okay. Wait, I'm struggling. This is the first time I've uploaded like an image, so this is definitely like new for me. Um, oh, here we go. Okay, I know how to do this. Lovely. So let's use this diagram, right? And let me crop it a little bit as well, so everything kind of pops up. Amazing. Okay. Lovely, lovely. Oh, actually, hold on. Nah, we'll use this. We'll use this. I can use this. Okay, is everyone able to see like the lines on this a little better? I'm gonna crop this so like it's a little clearer, hopefully. And we'll just have an extra small grid for today. Okay, cropped. Amazing. Are the lines on this a little bit clearer for everyone now? I know before is a little difficult to see. Um, yes, okay, lovely. All right, thank you so much again, Jason, for setting that. Awesome sauce. So let's now talk about some equations, right? Okay, so I'm gonna have a line that kind of starts from, let's say here, and let's say it goes over here. So this is what my line is gonna look like, and I will use orange. Okay, so that's my line, right? It starts here, it goes up there. There are several ways to express the equation of a line in coordinate geometry. Um, my favorite way is slope-intercept because I think it gives you the most information, right? So slope-intercept is like pretty self-explanatory. You have a slope and you also have an intercept. And that's it. Like that's what the line is, right? So every line kind of is a function. So we'll write it as y, which is whatever comes out on the y-axis, whatever number is the y coordinate, that's going to be equal to the slope m multiplied by the x coordinate, which is just x, and then plus the y-intercept, which is b. Okay, so the reason why this is basically like honestly how we express functions, linear functions in algebra. So this is very, very similar to that. That's also why I like this. It's a very easy like comparison. So the intercept, in this case, this is the y-intercept. That's where the line intersects the y-axis. You might be wondering like, why do we care about the y-intercept? I think it's because that's where the function is equal to 0, right? The y-intercept is when x is equal to 0. You can have, like, you can find the x-intercept. It's a little more complex. It's not as useful. The y-intercept is more useful. So we like to think of y as like the output and x is the input. So in this case, y is what we get after we do x, multiply it by the slope, and then add the b, the y-intercept. Okay? Awesome. So let's go ahead and see if we can find the slope-intercept form for this line. Okay, Radha asked, what is an intercept? An intercept is where the line intersects one of the axes, right? So this is our y-axis up here. This is, and actually, you know what? Let's delete this. You guys know what we're working on today. Um, this is our y-axis up here, and this is our x-axis, okay? So anywhere this line intersects the y-axis and the x-axis, that's an intercept. So in this case, we have one intercept, and in this case, we have a second intercept as well. So we have two intercepts here. Yeah, pretty simple, pretty simple. Good, so let's see, can we go ahead and find the slope-intercept form for this line? There are multiple ways to do this. Some are easier than others. But let's see first if we can get an equation. Okay, Nvika has already put one in the chat. Let's see what others say, if they're in agreement or disagreement, and we'll kind of go from there. Okay, awesome. So I'm seeing a lot of similar-ish answers, similar-ish, but not exactly the same. So I see um, y is equal to 4 over 5x minus 6 over 5. And it seems like most people have agreed with the slope. I am seeing a little bit of disagreement on what that intercept is. Okay, so let's go ahead and see if we can figure that out together. Starting off with the slope, right? I think this is pretty easy. Like you guys are masters at finding slope by now. So let's go ahead and do this really quick, right? We can do this visually. I think for the sake of this problem, let's actually go ahead and find the coordinates because that'll be more helpful going forward. So in this case, this coordinate down here is -1, -2, and this coordinate up here is 4, 2. Okay, so using our definition of slope, in this case, our slope will equal, we can do 2 minus -2. That's our change in y divided by 4 minus -1, which is our change in x. So when we go ahead and simplify that, we'll get 2 plus 2 in the numerator. So that's 4 divided by 4 plus 1 in the denominator, and that's 5. So our slope in this case is 4 over 5. Are we all on the same page with that? Yes, from Vaivehi, a nod from Kavya, yes from Vishit, yes from Sachi. Okay, good, good. I'm glad we're all on the same page. Wonderful. So let's go ahead and find the y-intercept now. There are a couple ways you can do this. You can use inspection, you can look at the diagram, but like I always say, it's never a guarantee that your diagram is to scale, so do not rely on that. The most reliable way I would say is go ahead and kind of like plug your slope back in, right? So right now we have y is equal to 4 over 5x plus b. Okay? So now what we want to do is we want to take one of the points that we know. We know that 4 comma 2 is a point on this line. So let's go ahead and plug that in. Let's go ahead, plug 4 over 2 into this equation and see what we get, right? So I'll do that in purple. So if I go ahead and do 4 over 2, my y coordinate is 2. And then I have 4 over 5 times 4. Man, I realize this is like at the very bottom of the screen. So let's make some space. And I think I can kind of like delete this portion. Okay, great. Delta. Okay, perfect. I want to leave these formulas here because I think that is helpful for some of you guys. And then plus b. Okay, so given this equation, can you guys solve for b? Like, what is b? Okay, awesome. I see a couple of people saying that b is -6.5. And I would absolutely agree. All you have to do is just solve this equation. I don't think we need to go in depth there. So yeah, -6 over 5. Did I say 6.5? My bad. So that is -1.2. I would not recommend you put it in decimal form. This is like kind of annoying. Fractions are more preferred. Fractions are preferred. So the equation for this line is y is equal to -4 over, or not negative. is equal to 4 over 5x minus 6 over 5. Okay. How do we feel about finding the equation of this line? Is this like, are we comfortable with this? It seems difficult now, but a lot of it is like just finding the slope and then plugging and chugging. So it's pretty simple algebra, which I think is why you guys will be good at this. Okay, good. Yeah, and Manit says we're ready for challenge problems. Good. So let's do a quick summary. There are other ways of expressing this. Honestly, it's not needed. Like it all comes down to this way. So I would say like this is probably the most important thing to remember. Okay. Lovely. Great. Let's see if there's anything else I want to talk about super quick. Okay. Great. Okay, so one thing to note is a lot of geometry problems, especially like 2D shapes and stuff, like triangles, squares, rectangles, whatever. A lot of them can be solved with just what we have talked about today. Like only using the tools we have today, you can solve a lot of those complex geometry problems. We won't get to that in today's class. That'll be a topic for another class. But I just want to show you guys like how powerful like coordinate geometry really is because you can represent basically the lines of any shape using coordinate geometry. So this is like a pretty powerful tool, but I would caution you not to like over rely on this like I did because that really limits your geometry knowledge, which is sad. Okay, so let's clean this up though, because I think we have a lot of good review problems to do using our newfound knowledge. And for now, I'm going to kind of minimize those formulas because I want to test your guys' ability to do problems without relying on formulas. So let's do a couple of problems and then we'll go ahead and end. Here is our first question. We'll do part A and then part B first, and if we have time, we'll move on to a second one, okay? So the first part is find the length of this hiking trail, which is the distance between R and S. Assume the trail is like a straight line. There's no curves or anything. I'll give you guys a couple seconds for this, like maybe 30. Manit, see if you can simplify that answer. Okay, awesome. So it seems like we have an answer for Manit. Let's see if anyone else has an answer, and then we'll kind of discuss. Okay, I bet he also has an answer. Awesome, awesome. Ah, it looks like we're also getting some answers for part B, but let's look at part A first. Okay, awesome. Okay, so it seems like Mani and Vaivehi have both fully solved this problem, which is awesome, you guys. Okay, Kavya has solved, I think part B is what I'm looking at. Part B, yeah. Um, okay, yeah. So let's take a look at part A first. Oh, and it looks like Anvika has got part A as well in very nice LaTeX format. Okay, but I'll have Manit unmute if you can to explain part A.
So first of all, you can just like find the difference between 2 and -4, which equals 6. And then you can find the difference of 5 and 1, which equals 4. So then 6 squared plus 4 squared equals 52. But then you gotta simplify that. So like 4 is 1. You can take out 2 squared from that, so it would be 2 square root of 13.
Yeah, absolutely. That is awesome. Thank you so much, Manit, for unmuting and sharing. I want to see if maybe Vaivehi would like to share for the next question, because I know she saw that really fast as well. If not, that's okay. But yeah. Okay, I think Vaivehi was able to unmute, but we are not able to hear you. Mics weren't working. That's okay. So let's do this last one together because I know we're kind of coming to the end of class. So for the second one, we are looking at the midpoint, right? So in this case, all you have to do is just take the average of the trail, right? Take the average of both coordinates. So starting with the x coordinate, the average is -4 plus 2 divided by 2. So that's -2 in the numerator divided by 2 in the denominator. So -1. And then for the y coordinate, that is 5 plus 1 over 2, which is 3. So that means our midpoint is -1, 3. Okay, so these are like pretty simple application problems. Not a lot of crazy stuff going on here, but I want to make sure we're all like kind of on the same page, understanding how these things work, because next week we will be applying a lot of these tools, and that can definitely get tricky. So let me pause here. How is everyone doing with these formulas so far, right before we end? And while I check for questions, okay, so it seems like everyone is doing good. So I feel comfortable giving you guys one last question. Uh, so for part, oh, whoa, that was crazy. Okay, here's part. You guys cannot read that, can you? Hmm. Okay, here's our last question for today. So yeah, part A and part B. Um, yeah, so part A is find the actual midpoint, and then part B is the claim correct? You do not have to explain, just tell me if the claim is correct or not. Okay, a quick answer from Anvika and Manit. Um, awesome, and Vaivehi as well. Okay, perfect. Let's do this one together super quickly. So the midpoint is once again just the average of P and Q, right? So the average of the x coordinates is going to be 0 plus 4 over 2, which is just 2. And the average of the y coordinates is 1 plus 5 over 2, which is 3. So that means that the midpoint is just 2 comma 3. And because that's what the students said up here, we say that their claim is correct. So yes. And on that note, I think this is an excellent place to stop for today. I know we're a little early, but you guys got this concept super duper well. I think next week will be definitely a little more challenging. So enjoy this break from some challenging content, and we'll do some crazy stuff next week. But thank you all so much for joining me, and I hope you all have a great night. Check out the handout that comes after this, and if you need to review anything, go check out the video on YouTube. All right. Thank you guys so much and have a wonderful evening. And I will see any of you guys on the advanced algebra class on Wednesday. Bye, everyone. Bye, Amari. Thank you so much. Bye, Anvika. Bye, Ratika. Bye, Tharos. Thank you. Yeah, bye, Rohan. Bye, Kavya. Thank you so much. Bye, Anvika. Awesome. Okay. For those of you guys still in the Zoom room, do you guys have any last minute questions or anything you wanted to share or ask? Okay, I'm gonna go ahead and end for now. So thank you all so much, and I will see you all next week. Bye.